Hey there! These are just a few examples of projects created with Rhino and Grasshopper. At first glance, it might seem absolutely unbelievable that anyone could design such forms by hand. Because honestly, they totally didn't. You see, behind all these complex shapes, there's a clear logic and an algorithmic system that transforms design from being guesswork and intuition to something precise and controlled. Instead of the designer sketching every single line and surface, they define the rules and relationships between the components. And then, guess what? Grasshopper takes that logic and creates the model all on its own. That's why this tool is such a key part of digital design these days, especially in architecture and parametric design. Today is the day you're going to learn how to bring that logic into your designs right from square one. I mean, we're starting from zero knowledge of Grasshopper, and by the end, you'll be crafting those smart, responsive forms like a pro. How exciting is that? So, let's dive in together. Hey there, I'm Hossein, and welcome to the very first session of the Grasshopper course from scratch on my channel. Finally, we've arrived at this course I've been promising for ages. It's the one where we're going to dive step by step into the fascinating world of Grasshopper. You know, Grasshopper is like one of the most crucial tools in the realm of algorithmic design and parametric modeling. And guess what? We're going to learn how to create models that are intelligent and controllable, all without needing to write a single line of code. Oh, and before we jump into it, I just want to throw this out there. I've also published a series of introductory Rhino tutorial videos on my channel. Trust me, going through those could be a fantastic prerequisite for this course. So let's get ready to embark on this amazing journey together. If you're not totally familiar with the Rhino environment and its basic tools yet, I really think you should check out those videos alongside this course. It'll make your learning journey way smoother, you know? In this series of videos, we're going to kick things off from the ground up, like what Grasshopper actually is, how you install and activate it, and basically how it works. And then we'll move on to creating real practical projects. So if you're into digital design, algorithmic stuff, and smart forms, this is seriously the perfect place for you to be. All right, let's dive in and take that first step on our Grasshopper learning path together. Before we dive into the software, right, we got to ask ourselves this fundamental question. Why Grasshopper? I mean, seriously, why should we even bother with it? Can't we just whip up whatever shape we want in Rhino or like other programs? On the surface, sure, with manual design and standard tools, you can create a ton of forms. But like, here's the kicker. Manual design only gets you so far. When your project is dynamic, when forms depend on data, or when you need to test and compare like dozens or even hundreds of variations of a model, that's when traditional methods just, fall flat. This is where algorithmic design steps in like big time. Instead of just whipping up a specific model, you're actually crafting a whole system that generates models on its own, based on logical relationships and data. Imagine you're working on a project that interacts with natural light, right? Instead of manually adjusting each panel, you could create an algorithm that calculates the angle for each panel based on the sun's position. How wild is that? Or, like in urban design, the overall shape of a building could shift depending on population density, wind speed, or environmental data. This is all about smart, flexible, and repeatable design, right? And this is where the true power of Grasshopper really shines through. You're not just a designer, you become someone who defines the logic behind the design itself. And, like, just to add a little something here, I've got another video titled, What is Grasshopper? On my channel. I dive into its history and how it came to be, plus a bunch of other cool info about Grasshopper. I'll drop the link in the description, and you can also check it out right on the video thumbnail. All right, so let's dive right into the software, yeah? Grasshopper, it's this super powerful plugin for Rhino, right? And get this, it's like already installed on the newer versions of Rhino. So To get it rolling, all you got to do is click that little Grasshopper icon or just type in Grasshopper in the command line, and bam. When you open it up, a whole new window pops up. It's like a separate space, but totally connected to Rhino, you know? This is where the magic happens, where we'll be crafting our designs in this logical parametric way. Now, unlike Rhino, where you're just dealing with lines and surfaces, in Grasshopper, it's all about components and how they connect with each other. Whatever you do in Grasshopper, it's like live streamed, right, in Rhino. So like when you create a point or a line or any shape, it's instantly showing up in Rhino too. And every little tweak you make to the parameters, bam, it updates in the model right away. I mean, think about it. Rhino becomes your design canvas, and Grasshopper is like the genius mind behind it all. We're going to learn how to sync these two together, turning our designs from just static models into this dynamic system. Now that we're in the environment, we really need to get to know the overall structure of Grasshopper, right? So the heart of this software, it's what we call components. Each component is kind of like a piece of a big old machine. They each do their own specific job. Like one makes a point, another draws a line, one calculates distances, and another combines or filters data. So really, by putting these components together and connecting them, you build your entire design logic. So like wires are those little cables that actually carry data from the output of one component to the input of the next, right? And this whole process of, data flowing between components, we call that data flow. I mean, instead of you like directly building the form, data just kind of flows and the form gets created. So like, for example, the point component creates a three-dimensional coordinate like X, Y, and Z. Then the line component draws a line between those 2 points. And that line's output, oh man, it could be the input for like dozens of other components. And that's exactly the essence of Grasshopper, Everything is built in this logical chain. Okay, so like at the top of the Grasshopper environment, you see this collection of tabs, right? So the params tab is for data, like numbers, text, points, vectors, geometry, and all that jazz. Then there's the math tab, which gives you access to mathematical functions. And the curve tab, that's all about curves. And the surface tab, yep, you guessed it, it's for surfaces. And there are so many other tabs, each one packed with its own special set of components. But like, here's a super important point. Anything you create in Grasshopper, until you hit bake, it's all virtual and dynamic. Like seriously, that means a real Rhino model isn't made yet. It's just this data-dependent geometry that keeps updating as you change the inputs. So baking it is like turning that parametric model into a real independent object inside Rhino. All right, so here we go. It's time to create our very first data, right? So to kick things off, I'm going to double click on that empty Grasshopper canvas to pull up the command search section. Now I'm going to type in construct point and just select it from the list. This component is super neat because it lets us create a 3D point, and get this, we can control the X, Y, and Z coordinates separately. All right, so let's dive into figuring out these coordinates. For this, we don't even need to pick anything from the menus, right? All we've got to do is double click on the screen, just like that. Then type in any number you fancy and hit enter. Boom. Grasshopper automatically whips up a number slider for that number. After that, it's just a matter of grabbing that slider with your mouse and connecting it to the X, Y, and Z inputs. Oh, and don't sweat it. I'll totally break down how we can customize and tweak those sliders later on. When you move the sliders up and down, right, you see that point in Rhino, like it just shifts in real time. It's all like the result of a few simple numbers that you get to control. This is like seriously the first step in parametric design, creating this controllable, flexible data that's totally dependent on parameters. And from this super simple starting point, we gradually dive into more complex algorithms. Okay, so here we go. Now that we've created our very first parametric point, it's time to use it to whip up some simple shapes, right? Making a circle. So I'm just going to grab the circle component from the curve tab and drop it right onto the canvas, The P input is all about the center of the circle, so I'll connect it to the output of the construct point. Easy peasy. Now, for the radius, I'm just going to double click on the canvas, type in a number, and hit enter to create a number slider. Super straightforward. I'll hook this slider up to the R input. And, get this, if you change the slider value, you'll see the circle expanding and contracting in real time. Like, how cool is that? It's just like Rhino, but here, everything is controlled by numbers, not by hand. Okay, so when it comes to creating a line, right, it's kind of like you need to think about it in the same way. So this time we need 2 points, right? One for the starting point and one for the ending point. So like I'm going to add 2 construct points, And for each of those, I'll set up sliders for X, Y, and Z. It's pretty straightforward. Then I'll connect those to the start and end inputs of the line component. Now, here's the cool part. When I mess with the sliders, the line, it moves around like a living creature in space. All right, so making a box, it's kind of like this, right? You just need to have a base point, and then, you can totally use a few number sliders to set the length, width, and height for your box component. And guess what? When you tweak those 3 parameters, your box changes in real time. Like it can get shorter, taller, wider, however you want it. These 3 examples are like your first serious steps into parametric design. What's really crucial here is the numerical control. You're literally just using a couple of simple sliders to create geometry that's totally adjustable and repeatable anytime. So let's dive into something super important about Grasshopper. Yeah, like how do we actually bring in objects from Rhino into Grasshopper? I mean, think about it. We often have this mixed design, right? Like one part of our model is crafted by hand in Rhino, and then we want to parameterize another section. So we really need to know how to connect these 2 environments like seamlessly. Okay, so like we're diving into the params tab, right? And oh man, there's this whole set of components that are like specifically designed to grab geometry from Rhino, So first off, we've got this general component that can take like any kind of geometry, point, line, curve, surface, or even a volume. Isn't that wild? And then like there are these specialized components like point, curve, brep, and mesh, each one tailored for a specific type of geometry. First things first, we got to place the component we want right on the canvas, right? Then we just like right click on it and choose either set 1 geometry or like set multiple geometries. Totally your call. After that, we dive into Rhino and pick the object or objects we want, yeah? And as soon as we make that selection, boom, the geometry just transfers over to Grasshopper. Okay, so here are a few important points, right? When you select multiple objects using the Set Multiple Geometries option, they all come in as a list into Grasshopper. You can make parametric changes to all of them at once. Like, who wouldn't want that? And, if you later edit the Rhino geometry, all you have to do is hit recompute in Grasshopper, and boom, your output is updated. Okay, so before we bring the objects from Rhino into Grasshopper, we really need to understand how Grasshopper classifies and manages different types of geometry, right? It's super important because the type of component you choose totally dictates what data gets funneled into your parametric definition. So in the params tab, we've got several groups of components, each specifically designed for a particular type of geometry. Let's go through them one by one. Geometry, right? It's like this universal entry point for everything, The geometry component, it's super versatile. It doesn't matter if you're dealing with a point, a line, a curve, a surface, a volume, or even a mesh. It can handle it all. Isn't that wild? So you use this component when the exact type of geometry isn't clear, or when your design needs to accept different types of geometry all at once. It's pretty safe, but honestly, it's way better if you know exactly what kind of geometry you're working with, right? So point, right? It's all about those individual spots, literally just single points. So whether you're picking a point in Rhino or creating one with your own coordinates, it's got you covered. And it's super handy when you're working with coordinates or dealing with a whole bunch of points, like a grid or control points, Now, moving on to curve, which is totally for any type of line or curve, okay? We're talking about straight lines, arcs, NURBS, splines, and even polylines. So whenever your input is a path or a curved profile, that's when you pull out curve. Let's talk about this thing called surface, right? It's just this flat two-dimensional thing, So the surface component is used for shapes that don't have volume. Think about it like this. You've got a simple plane or a curved surface, and then there's a patch or even a loft before it becomes a solid. So if your geometry is just a surface and it's not closed, then surface is totally the way to go. BREP, right? It stands for boundary representation, and it's one of the most important components out there. This thing can handle complex surfaces, and it can also deal with open and closed volumes. So think about it like this. You've got examples like a cube, a cylinder, or even those intricate shapes modeled in Rhino. And don't forget about geometries made up of multiple surfaces. Now, here's where it gets kind of interesting, right? The difference between BREP and surface is super. Surface is just a single surface, but BREP, it can be a whole collection of surfaces or a complete volume. All right, so here's the deal with mesh, right? It's all about those polygon geometries. You see, the mesh component is for models made up of polygons, especially when you've imported OBJ or FBX files. Or maybe the model came from another software, Or, get this, you might have even created a mesh yourself using Weaverbird or Rhino tools. Meshes process faster, but they don't quite have the precision of NURBS. So, yeah, you get speed, but you trade off some accuracy. So in the params tab, choosing a component is super crucial, right? You're picking the type of geometry, which is kind of everything. So you've got geometry, that's all the things. Then there's point, just a single dot. Curve, think lines and curves. Surface, that's your flat stuff. BREP, complex surfaces or volumes. And then mesh, those are your polygons. Now, here's the thing. Picking the right one makes your parametric definition way more stable, faster, and super accurate, And every object you bring from Rhino into Grasshopper stays dynamic. If you change it in Rhino, Grasshopper updates automatically. This means you can create these precise and professional hybrid models without having to start from scratch every time. Okay, so one of the big questions that pops up when people start with Grasshopper is do I have to learn everything from scratch? And the truth is, no, not really. Most of the commands that we use in Rhino, line, circle, move, extrude, loft, scale, they're all right here too. But instead of just running them once and being done, they're available as components. So you can take them and like plug in new inputs every time to get fresh outputs. It's like the same commands from Rhino, just with this cool parametric twist that makes them totally adaptable. You've seen how, like, with just a few numbers and some simple connections, we can create geometry, right? But here's the kicker. You're not just working on the final result in Grasshopper. No. You're actually working on the process of making it all happen. In Rhino, you're building the model, and if you want to change something, oh man, you got to go back and rebuild or like manually edit it. But here, we're creating a system that can react in real time, update itself, and generate new forms on the fly. In the world of architecture, picture this. You want an entire plan to open and close based on the distance from light. Or how about the facade of a building changing with the intensity of the sun? Now in Rhino, you'd have to redesign all of that manually, but here, all you need to do is tweak the light input. Just change that one thing and the rest of the model reacts on its own. That means you're creating an intelligent model, not just a static one. A model that has logic, conditions, takes inputs, and produces outputs. That's exactly what takes Grasshopper from being just a simple modeling tool to a full-on environment for algorithmic design. Up until now, everything we've been working on has been like super parametric and totally tied into that algorithm, you know? But sometimes you really need to switch gears and turn your geometry into a real deal Rhino model, right? Like for rendering or outputting, or even just to keep going with some good old-fashioned manual modeling. And this is where we hit one of the most important tools for connecting Grasshopper and Rhino, like big time. If you want to convert your parametric geometry into actual geometry in Rhino, it's super simple. Check it out. 1, just right-click on the component that's producing the geometry. Easy peasy. 2, then you pick the bake option. Got it? 3, Rhino's going to ask you where you want the geometry to be created, like which layer. Just choose your layer. 4, and boom. Now your output pops in as a standalone object in the Rhino space. Now, here's the big thing to remember, okay? The baked geometry is no longer linked to Grasshopper. So if you mess with the slider, right, here's what happens. The Grasshopper version changes, but the Rhino version, it stays put. It's literally like taking a snapshot of your parametric geometry. Let's talk about the important uses of baking, right? So first off, you've got rendering in engines like V-Ray or Enscape, which is pretty neat, right? Then there's outputting for 3D printing, which is like super fascinating. And oh, check this, outturning parametric geometry into regular models for manual editing. Like, who even thinks of that? That's some next level stuff. Up until now, you've totally gotten familiar with this whole parametric design logic. You've figured out how to define numerical coordinates, create points, and even extract circles and lines from them. And like, you've seen how components connect with each other, building this smart model. It's honestly the most foundational part of the Grasshopper world, creating geometry from scratch, having complete control with parameters, and understanding data flow. Now, moving on to the next part, transformations. Oh man, in the next section, we're diving into one of the most exciting bits, transformations. Move, rotate, scale, and even bend and twist. This is where you'll see how a simple geometry can totally change shape with just a few parameters and show off some pretty complex behaviors. This is the first episode of the Grasshopper tutorial. In this session, you got to know about parametric design logic, right? You created some coordinates, made points and curves, and you saw how everything can be controlled and changed with just a few simple parameters. And from here on, we're diving into the more exciting parts. If you haven't subscribed yet, like seriously, do it now so you don't miss the next episode. Thanks for sticking with me through this video. I'm Hassan, and until next video, see you later.